Hello again, Mr. Dodd, working through the limit definition of a derivative unit as a part of calculus. We have a lot more background information, or the overview is a lot longer than what I would normally do. But because this is such a transition point, I want to make sure everybody's on the same page as we start to work through. So a derivative, just to define it, is an equation for the slope of the tangent line of a given relation. We abbreviate that as f prime of x if we're given function notation, y prime, or dy dx. There's a couple different ways, but those are the main ones that you'll see. They all mean the exact same thing. So f prime of x is the derivative of f of x. Y prime is the derivative of y, and then dy dx means the derivative of y with respect to x. The main reason why we talk about derivatives is so we can find the slope of the tangent line. And there's a bunch of really interesting applications of the slope of a tangent line. For example, if you have a position graph, the slope of the tangent line at any given point along that tangent graph is the velocity of that object. So that would mean we don't have to have two graphs, we just have to have one graph, and we can actually find the velocity, which is really nice. So we're going to talk about estimating the slopes of tangent lines with a secant line, which is where everything begins. And then we're going to take that idea and apply the limit process to be able to find an exact derivative. And then what are our uses, like the basic uses of derivatives, finding slopes, writing equations for tangent lines. We're also going to talk a little bit about graphs and what graphs of derivatives look like. So there's a lot of stuff going on in this unit. That's why I wanted to make sure we knew. Other things that I want to make sure we know about are the difference between a secant line and a tangent line. So a secant line is going to cross the graph at two separate points, and a tangent line crosses the graph at exactly 1 point. Okay, this dot right here is simply because of the fact that it crosses the x-axis, but it only touches at exactly 1 point. That's what makes it a tangent line. So that's the difference between these two. We're going to use secant lines, but what we really want is the tangent line. The reason why we have to use a secant line is, if you remember back to the background information, how do you find slope? Well, in order to find slope, you need 2 points. And a tangent line only crosses at 1 point. So how do you find a slope if you only have 1 point? And that's why secant lines are useful for us. And then the tangent line is what we really care about. So we're going to try to estimate that, and then we'll figure out a way to toss out the calculus, or the little pebble, which I'll talk about in a later video, and actually be able to find the exact slope of the tangent line, the exact equation for the slope of the tangent line. And then just a couple potential issues. So if I have so in general, functions will not have f prime of x, so a derivative, at these 4 things. So if you have a vertical asymptote, they're not going to have a derivative. If you have a jump, so let's say this was a piecewise function with a solid dot and an open dot right there, that's a jump. That's not going to give us a derivative. Sharp points don't give us derivatives because there's lots of different places I could draw. If the tangent line only touches once, I could draw a line that touches once with a negative slope. I could draw a line that only touches once with a positive slope. So they create a little bit of a weird spot for us. And then same thing here. If I have an undefined slope, there's all sorts of tangent lines there. So we don't, in general, we don't have derivatives at those points. Now, just like we talked about in with limits, any point along this line, so this is an absolute value graph, everywhere except for this point has a derivative, or has a value of a tangent line, just not that specific point. Okay. That's about it for just a general basic guideline of where we're at, and then I'll start going through the learning targets, so stay tuned for those.